Hello, everyone, and welcome to another episode of Generative Geek. Today, we are going to talk about multiple PDFs. How do you take multiple PDFs and build your own question answering agent with it? In the previous video, which was about PDF question and answer, where we built a PDF question and answering bot from scratch with Google Gemini and ChromaDB. You can see, this YouTube video has links to the collab notebook and all of that. We built everything from scratch, but this was a single PDF. Now what I'm going to do is I'm going to take multiple PDFs, create chunks out of them, then save those chunks depending on the PDF in a different collection. So they are not going to go in the same collection. While you can put it in the same collection, what I'm trying to simulate here is a multi-retriever kind of a situation, right? You know that there are multiple tables, multiple collections which have data, and how do you bring data out of them and put it as part of the context and then send that as a prompt back to Gemini, right? That's what my goal with this video is. So let's get started. We'll build everything from scratch. We are not using LangChain in this video. So we'll be using Google ChromaDB. We'll be using Google Gemini and ChromaDB, right? Let's get started. And as part of this video, what we'll be doing is we'll be building on this same collab notebook, for which the link is already available here as part of this video. We'll be building on top of it. So I'm going to rebuild some of these things, not rebuild, but reuse some of these things, right? So I'm not going to explain a lot of what was done. I'm just going to reuse them just because, we have already done the explanation in the previous video when we build these splitters, when we built how do you save those embeddings into ChromaDB and all. I'm just going to reuse a lot of it now. So let's get started. The first thing is I'll just copy these cells. I want to install these dependencies. This is our large flow. We'll be using request to download the PDFs of interest. PDFs of interest. Then we'll load the various PDFs. We'll chunk the PDFs. We'll create our own splitter. We have already done that in the previous video. We'll then use Google Gemini embedding function for creating these embeddings. Next, what we are going to do is we are going to create separate ChromaDB collections. Now this is the keyword here, right? So we are going to use separate ChromaDB collections here, right? It's not the same collection in which, and I'm going to put some metadata as part of each collection, and you will see why, right? And then we'll add metadata and ingest these documents. Basis the query, we'll find relevant passages. We'll send these passages as context. Again, similar way here, we'll find the interesting similar results. We'll put that as part of the context. We'll add the query into the prompt, and we'll send the query and the context as part of the prompt to Gemini, right? So this will be our goal here. The dependencies are all getting installed. When they get installed, we'll know, it'll all be done. Now, let's quickly configure the Gemini client, right? So same way, I'm again reusing most of it. You will have to give access to the Google API key. And then once this is done, even this cell will start running. Next was we were printing what all models are available. So I'll just go out and print some of these models. If you have, what you can do is you can open the same collab notebook and start copy pasting if you have already gone through that video, right? So these are the various models that are available. This also tells us that our key is working. Next we'll build the method which will download the various PDFs, right? It's the same method. We are just building the same method here. And in case if something is changing, I'll come back here to this PDF and I'll, change that. Maybe what we'll need to do is, okay, I forgot to mention that, in this video, what I'm going to do is I'm going to use screener.in. It's an Indian stock investor data. And I'm going to talk about 3 companies. Let's say I'm interested in 3 companies and let's say I'm an analyst and I am interested in IT services sector and how their future looks like, given that generative AI can do a lot of work now. So how is the services sector in India for the IT sector? How is it going to do, right? So let's just say if that is my goal, I will come here to screener.in. It's a free tool. Highly appreciate this tool and its makers. Amazing work these guys have done, and it's all available for free. So I'll come in here and I can see transcript notes, right? So I'll just go here, copy the transcript URL. This will become my URL of interest. So these are like, the conf call earnings conf call transcript for the latest conf call that they would have done. These will become my URLs of interest. So I'm just going to save these URLs, and I'll take three companies. Like I'll take Infosys is a large company, TCS, which is which is the largest services IT services company in India. I'm going to go to that, and again same way I'm going to download their transcript as well. So this is the transcript. Then same way I'll take the third company, HCL Technologies, and I'm interested in them as well because they are very large. So if these three companies, whatever they say collectively, is basically the mood of the IT sector, right? So that's my goal here. So I'm going to take these three URLs and I'm going to get started with them. So let me just bring in the code. What I'm going to do is I'm just going to say download PDF. These are my URLs now. These are the URLs of these various files here. And we'll just run this, right? So for URL save path, print save path, save paths.append. Yeah. So let's just see if this works, right? I don't know if I ran the previous method. Missing save path. Download PDF is missing save path. Okay. I think what I can do is I just need to change this a little bit. What I don't want to always keep presenting it with the path. Also, what will happen is when we are downloading from public websites like exchanges, they tend to disallow scrapers. So maybe what we'll do is for educational purposes only, we will mimic this request as if it is coming from a Google Chrome, right? So we'll say headers to mimic Google Chrome. We're going to say we're going to create a dictionary which will have the user agent string for a Mac which is using Firefox right now, Chrome right now, right? So I'm going to mimic this, and we are going to say URL request.get URLs and headers is equal to headers, right? This way it is going to send these additional headers as part of the request, right? Next, what we are going to do, if save path is default, then I want to just say if save underscore path is equal to default, I want to basically find the file name. I'll take the URL and I'll split it by a slash, and I'll take the last of it, right? So whatever is this URL, I'll take the last. So this is what I'm interested in because I'm splitting on these slashes. So the last one is what I'm interested in. So this will become my file name. And next, what I'll do is I'll say save path is nothing but os.path.join, whatever is the current working directory, os.getcwd, and I'm going to attach the file name with it, right? So this becomes my save path. Next is same file.write, and we are just going to return the save path, right? So that's what we are doing here. We are going to return the save path. Here I was not writing the save path. Okay, I was doing it. And this way, so remember guys, previous one was just for one file, right? This time we are saving multiple files. So we had to make some changes in the code. I'm going to rerun this function and again rerun these URLs and hope that this time it works. If it works, I should see these files. I can see the files coming up here. So that means the code has started to work. It is also giving me the location because I was printing the save path. This is the location where it has got printed, whatever was the save path. Next, it's simple. What we need to do is we have now saved this. So let's go back to the instructions. We have loaded the various PDFs. Now we need to chunk the PDFs, right? And in order to chunk the PDFs, we first need to read the PDFs. So we are going to take the same code. We are going to take the PyPDF2 import reader. Let me just expand this a little just for readability purposes. So from PyPDF2, what we'll do is we'll come back here and we'll use the same code, right? So we are reading the page here. We are loading the PDF and we are reading the page, right? So next, what we'll do is we will, for each of these, what we want to do, we want to go back and read the PDFs, and because there are multiple PDFs this time, so what we'll do, we'll create an empty dictionary called PDF underscore text, and for every file that is available in save paths, like save paths were these three paths, so every file in this, we are going to load the PDF. Then we are going to capture the file name, and we're going to say, hey, in this dictionary, this is the file name. This becomes the file name, becomes the key. The last one, which is basically this will become the key. This becomes the key, and we are going to save the text of the PDF in as part of this dictionary, right? So I'm going to run this, and we can quickly see if I do PDF underscore text, we can see, okay, I should have done dot keys or something like that, because this will have entire thing. Let me just say what are the keys, and you can see these are the various keys, right? So these are the names of the files. These are the names of the files, right? Now, one interesting thing what we can do is, we have these files, right? When the user is uploading, let's say if there was a Streamlit app where the user could upload these files, or there was some PDF getting sent to you, the machine doesn't know which company is being talked about, right? So what we are going to do is, we are going to build an interesting new method here. We are going to say, for each of the keys in the PDF underscore text, send a request with first 500 characters. Oops. Send a request to Gemini. So we are going to read each of these PDFs. We have already read them. The values are stored in PDF underscore text. We are going to take the first 500 characters and send them to Gemini, and find the name of the company that is being discussed. Yeah. So the name of the company that is being discussed in the report, right? Or name of the company this report is about. Okay. And then we'll say change the, okay, I'll leave it this. We'll just be about this. So we'll say def build prompt for company name, and we are going to send it some text, and we are going to say prompt for finding company. So we'll now build a prompt. We'll send this prompt to Gemini first. Now this is something that I'm doing additional, but it will help. It'll all become clear to you why I'm doing this, right? So we are saying prompt for finding company is, you are an expert at reading conf call transcripts and annual reports, and finding the name of the company being discussed by going through the first few passages of transcripts and reports. You are being presented with initial passage up to 4,000 characters from such PDF reports below. Your task is to output company name as part of the answer. Company underscore name as part of the answer. Do not output anything else. Context is text. Answer and return is prompt for finding the company, right? So this prompt, it should return. I'm just going to send the first 4,000 characters, not for 500 characters. And then we'll say def generate company name. And from there, we'll basically send the prompt to Gemini, right? So same way, our model is, in order to get the response, we'll have to pass three things. We'll need to pass the model. We are using Gemini 1.5 Pro latest. Company name is model.generate content prompt, and return company name.text. Now I'll have another method which will be def find company name, and we are going to pass it the text, right? So using this text, we'll build the prompt, we'll build the company name, and we are going to return the company name, right? So yeah, so these three methods are ready. We have three methods. First, we are going to find the company name. For that, we need a prompt. This prompt will basically we'll send this prompt to Gemini, but along with this prompt, we are going to send first 4,000 characters from the PDF reports, right? And it should give us back the company name, because we are asking it that your task is to output company name as part of the answer, and it do not output anything else. So let's see what comes back. Again, we'll say companies is equal to an empty dictionary, and we're going to say for key comma value in PDF underscore text dot items, company underscore name is equal to find company name, and we are going to pass the first 4,000 characters, right? So the value is basically the key value. The value is what the contents of the PDF, right? And we are going to say companies key is equal to company name, company underscore name, but there could be some empty strings and all of that after this. So we are going to strip all of them here, right? So we are going to do some R strip, and we are going to say print f company name for key is company name. Okay, so let's see what comes back. It is going to make a call to Gemini. It is going to send those first 4,000 characters, and company name for this is HCL Technologies. Okay, company name for this is Tata Consultancy, and company name for this is Infosys. I could have easily skipped this step, but this is another interesting way of just sending few things, few text to Gemini and letting it infer what the model, what the text is all about, right? So, and that was the reason I let it do it, right? So next, our this is done. What we'll do is we'll copy this split text function. So we are just going to take this split text function, we are going to reuse it. Now we have these PDFs, we know the name of the companies. What we want to do is we want to now go out and generate chunks, right? So in order to generate chunks, what we'll do, we'll say for key comma value in PDF underscore text dot items. We will say PDF underscore text, and we'll give it a key is equal to split text recursively. We're giving it the value, and we are saying max length is 2000 and max chunk overlap is 200. Okay, so we are just replacing the value with these with the list of these chunks. Earlier PDF text was holding the entire PDF content. Now we are just replacing the value. I can easily also create another variable, but because I don't need the original PDF after this, so I'm okay letting it rewrite, right? So also I can just say that let's just also print the chunk count. So we can easily say print split text for this into these many chunks. So let's just see how many chunks were there. Okay, sorry, this time it will be a problem. We'll have to rerun this, because and this is what happens when you reuse the variables. I ran that earlier. Okay, now let's just again reuse this, rerun this. And let's see what comes back, right? I am rerunning all the cells, and the whole reason for rerunning was because so it's saying that this text was split into 31 chunks, 32 chunks, 51 chunks, right? So we have these many chunks now these chunks are available. As a logical next step, what we need to do is these chunks need to go into different collections. That's our next goal, right? So what we'll do is we'll come back and we'll say import ChromaDB, and we'll say this code should be here. So we'll just say import ChromaDB. This is the embedding function we are using. Import ChromaDB.utils underscore embedding, and we are going to say we are going to use the same Google Gemini EF function, right? So the Google EF, Google Generative AI embedding function, I'm going to use the same. Our persistent client is going to be in embedding slash Gemini. All of this looks okay. So we'll just run this. This will basically instantiate my ChromaDB and a client to work with that ChromaDB instance. Right now, what we want to do is we want to take each key, which basically means for there are three keys. There were three PDFs, so there are three keys in PDF text. We are going to take three keys. We are going to loop through them, and we are going to define a we are going to define a list called metadatas. I want to say metadata is equal to company underscore name colon company's key, right? So I'm basically saying for each key I'm giving it the company name, right? So whatever is the company name, I'm giving it that whatever the name we found here, If you remember, we were finding the name and storing it in some key. I'm storing the key is still the same. Key is the file name, and we have the value as the company underscore name. So we are again doing the same thing. We are creating a metadata where I'm saving the what is the name of the company. And I'm, as part of my ingestion into ChromaDB, I'm also going to ingest the name of the company that we found, right? Now, this is a very specific example for this stock kind of an environment that I'm building. You can easily skip the metadata part, right? And you can just say, hey, let me just ingest everything in one place and make queries on top of it, right? Because my queries are going to be about companies as well, and how each company is thinking about growth and all of that. Therefore, I am ingesting this company name as part of the metadata, right? So for I in range, len of pdf underscore text key, what we are going to do is we are going to keep looping through all of this, and we are going to say metadatas dot append metadata. You need as many chunks are there. You need that many metadatas to go in, and therefore we are just creating a list of metadata here, right? So we are not doing anything else special here. We're just creating a list of metadatas, all with same value actually. If you look at it, we are not changing the metadata, it's still the same, right? I'm just creating a list of metadatas, right? And then what we are going to do is we are going to say IDs is equal to strid. When you insert documents into ChromaDB, there are two things you need to do. One is the document and the other is the ID, right? This you need to definitely give. So I'm just creating an ID. ID has to be a string, so we are just doing that. And then what we are going to do is we are going to say collection is equal to client dot get or create collection. This time we are creating a collection with the name of the key, right? So the key is basically my PDF file, and I'm going to create a collection with the name of the PDF file, right? So this is the key, and I'm going to create a collection with the name of the PDF file. So for each PDF, there is a collection that is going to get created. So we have 3 PDFs, 3 collections are going to get created. And next, I'm going to add to the collection IDs and the keys. These become my documents. So IDs is equal to IDs, documents is equal to this, and metadatas is equal to metadatas, right? So I'm adding all of this. I'll run this. This should create 3 collections, and I can quickly see once the collections are done. We can say collections is equal to client dot list underscore collections, and we can run for collection in collections print call dot name. So let's see once this runs, what will come back. We should see 3 collection names, and given the fact that the key is the collection, we should see the key names here, right? You can see that the 3 collection names are printed. These are the names of our PDFs. With this, we now have the collections ready. If you want, we can even go in and say, hey, print call.name, print call.count, right? So this will tell us how many objects are there within each collection, and you can see as many the chunks were, same are the number of objects in each collection, right? 31, 32, 51. With this now we are now at a point where our ingestion is done. Along with the metadata, our ingestion is done. We can also, yeah, so our ingestion is done. Now what we need to do is we need to work on this part where we'll take a query, send it to ChromaDB to find the nearest neighbors, similarity search sort of, and then that gets added as part of the context. The only difference is whatever is the query now, we want all the three collections to be queried. We don't want just one collection to get queried. We want all the collections to get queried. So that is the part we'll build now. We'll come back to this again, the same thing. We have the chunks, we have find relevant context. Um, okay. Just Slightly confused. Where were we? Yeah. Okay. So we have the split text. We chunk the text. We have the chunks now. We have the collection. And now what we want to do is, so what we are now going to do is whatever is the context that comes back when you retrieve information, the context will come back, right? And I want to now basis that context. I want to, so let's just build the context first, right? And we'll come back to the escaping context part later. So let's say we want to build the context. This is the part where I'm going to take a query and I'm going to pass this query to various collections and build an informed context, right? So basis all the information that I get, I'm going to pass the query to various collections I already have, and I'm going to say collection is equal to client dot get underscore collection, and name collection dot name is my will be my collection name. And when you are getting this, you have to also specify the embedding function that was used. So our embedding function was Google EF, so I'm going to specify that collection. So now that you have the collection, we can quickly print the collection as well. And we can also print collection dot count, just so that we know how many objects we have and if it is fetching the right way or not. Next, what we are going to say is we are going to say collection dot query, and query underscore text is going to be the list of query elements that we are going to pass, right? And we want three results to be returned back. So n underscore results is equal to 3. This way, now what is happening is we are taking a query and we are looping through each of these collections and we are building a result, right? So when I go to the first collection, it'll go to the first collection with the query, it will find whatever is relevant, bring those top 3, right? And so that becomes part of the result. Now I also know the company name. So, and the company name I know because the metadata that I stored, if let's just say we run till here for now, right? So let me just run till here. This is the method and will rebuild the method now. And I say we want to build the context. My query is, let's say my query is, how is the growth outlook for IT sector in the backdrop of generative AI, right? So let's just say this is my question query, and I send this query to build context, right? So let's see what comes back right now, and I'll just return the result for now. So this is my result, and we'll run this method, we'll run this, and we'll print the result, right? So let's see what comes back, right? If you see 31 objects, it is polling through this. These, we will get results in this way for now, right? So it went through the first collection. For collection in collections, it went through the first collection and it gave me the collection name, collection count, and what was the result, and then immediately returned, right? Because we had this return, so it immediately returned. And if you now look at it, we had inserted this metadata. So you will see this list of metadata all with same name. This is the part we did when we were building the metadata. We had done this part just before we ingested. We added this metadata, right? So the metadata part is allowing us to get the metadata now from the result. So I want my informed context to also have name of the company so that we know which company this passage belongs to. And I'm just going to say result is collection dot query and company underscore name is equal to result. So if you look at it result, then you have the metadatas. So I'm going to read the metadatas, and I'm going to read the first element, which because it's a list of lists. So I'll get another list and I want to read the first list again and the company underscore name. So I'm going to read the first list again and then we want to read the company underscore name, right? This way I'll get back the name of the company along with the result. Next, I'll say text is equal to, at this point, if you look at the text, right, that is coming back, it has a lot of it is not escaped, right? So it has a lot of characters. it might have a lot of breaks. So we have built a method called, we'll build a method called escaped context, which we had built in the previous video as well. And I'm just going to copy from there. What it'll do is it will just build one large string for each of these lists, right? So this is a list. There are three items that are getting returned, and but we'll build one large list, one large string out of it. Instead of a list of lists, we are going to build a one large string, right? And so I'm going to take the company name, and this I want to pass to the text will be build escaped context, and we are going to pass our result. Within result we have documents, and I want to pass the first list to it, right? So if you look at this, all of the text that is coming in metadatas, we have embeddings, and then we have documents. So I'm passing this documents, the first list I'm passing it. It's a list of lists, so I'm passing the first list, which again has three, which will have three elements, right? So this will then go to this method and say, hey, keep running it and keep adding whatever you see, just keep adding it and give me one large string, right? So this will become my text. Next, what I want to do is I want to build the informed context. We have already set the informed context as an empty string. I'll say it's a, I'm going to add the company name as well to it. So company is company underscore name, and I'm going to add to a few empty line breaks, and we are then going to say text from company underscore name is whatever is the text, and we are then going to say informed. We are not going to return the result. We are going to say informed underscore context. Something doesn't seem right. Okay, there are three extra characters that came up. Informed context plus is equal to informed underscore context, right? So I'm just adding to this string whatever I'm building here, right? So this is what I have done. I'll maybe add some extra lines here as well, because this will become big as more and more companies get added. So informed context will keep getting built this way, and finally once all the loop is done, I want to return informed contexts, right? So this is the method that will help us build the context, right? So I'm building the context. I'm querying all these three collections. The three nearest results came out. I'm now parsing them and building a context, and this context and the query I'll add to the prompt. So the next step now is building the prompt, right? So now let's get to the point where we are building the prompt. I'm just going to take the method from the previous Google Colab notebook, and I'm going to say def create prompt for Gemini, and our prompt will take the query and the context. So you are a helpful agent that answers questions using text from the context below. Both the question and context is shared with you, and you should answer the question basis the context and not hallucinate. If the context does not have enough information for you, inform about the absence of relevant context. Your answer should have two parts. First part should give one macro answer basis the complete context. Second part, the answer should be about each company basis the context and the question asked. Both the parts should be focused on the original question and help the reader with their original query and its intent. If there is no relevant context for a specific company with respect to the question, you should mention that. So I'm passing in, I'm basically saying, hey, give me two parts. The first part is the macro observation. So like, our question was, how is the growth outlook? First is the macro, that, hey, I went through all of these contexts, and this is what I feel about the macro. Then second is about each company. How is Infosys thinking about it? How is TCS thinking about it? How is HCL Technologies thinking about it? It is going to tell me that, right? And so this prompt is now ready. I'm going to return the prompt. Next, what we need to do is we need to generate the same question, same method that we had earlier, where we are saying when we fetch the company name, um, where were we making the call? Okay, so our similar method, but instead of def generate company name, this time we are just going to say give me the then generate answer from Gemini, right? Maybe that would have been a better name earlier itself. generate answer from Gemini. Whatever prompt you give it, it will give you the name. It will give you a result, right? So these two things are done. My prompt has got built in the previous method call. My answer will come from this. This is my query now. Context. I now need to, in order to build the prompt, I need context and query. Query I have, context I'll build. So I'll say build underscore context basis the query. So this is the method that I'm calling build context. It will build the context. Then once the context is built, we next want to create the prompt. We're going to say def create prompt for Gemini. We are going to give it the query and the context. Then the result is generate answer from Gemini, and this will become our answer. And I just want to print the answer.text, right? So this is what it is. Now let's just run this and see what comes back, right? How is the growth outlook? Something went wrong. Key error document. I think it is documents and not document. It should be documents. Yeah, if you, I don't know, maybe we have overwritten that cell, but it should be documents. So we'll rerun that cell, so that the method gets rebuilt. Now we'll again run the query. How is the growth outlook for IT sector in the backdrop of generative AI? Let's see what comes back. It has to make 3 calls to Gemini, so it can take a little bit of time. Be patient with it. Macro observation. Generative AI is expected to impact IT sector in a couple of ways. In some cases, generative increasing software spending, but reducing services spending, as some customers are looking at outsourcing more of their work to IT service providers, while also expecting vendors to absorb some of the cost increases. Are consolidating their technology spend. They are expected to pick it up back to invest in AI and other. So it gave us a macro which seems neutral, yeah, but overall positive that more work is going to come. Now, company observation. For company, HCL sees opportunities as it is enabling it to gain market share in software. Customers are looking for more or less from providers. Then you have from Tata Consultancy Services, they are being cautious as widespread adoption will take time. Bigger opportunities in application development, maintenance, and deployment automation. Seeing gains in productivity through Gen AI. While clients are pushing for more work at the same price, they are not asking for lower rates. The company is bullish on its prospects as it believes it has a leadership position. So we can send another query, like, something like, what are some of the interesting projects they are working on and things like that. What are some interesting projects or trends in the retail sector? So let's see what comes back. So this is, guys, this is how you can build generate answer. Answer is generate answer from Gemini prompt answer.text. Okay. So what are some interesting? So like this, you can actually build an agent that can go in, do the polling calls for you, build relevant context, take that context, build it as part of the prompt, send the prompt to Gemini and give you the answers, right? So macro observation across there are growing trend of enhancing customer employee within retail. Companies are modernizing their loyalty programs, leveraging AI for personalization, exploring retail media networks for revenue, and improving security. Interesting. Company context does not explicitly mention retail specific projects. Okay. TCS highlights a partnership with American office supply retailer to revamp their loyalty program. Infosys that are leveraging Gen AI to develop use cases for business value, large engagements in HANA, infrastructure, application. So like this, if you have more companies, and you don't even need 3 collections. If you ask me, this was more of a demo. So we built 3 collections. If you can have one collection and append the metadata, right? The right metadata. But then your query has to be changed where you will also make the metadata part of your query, where you will say, hey, go through each of these metadatas also. Not right now, we were going through each collection. When we were building the context, we were going through each collection. That time you will go through the metadata, unique metadata. Your query will change. You will say it will have more where clause. If you look at ChromaDB documentation, metadata query, right? So let's just say usage guide, guides. I don't know. I'm also just going to search querying a collection, right? So if you see where the metadata field is equal to this, something like this, you will have to do where you will say, hey, your query is not just going to be query text. You will also have to have a where clause where you will specify the metadata value. And in our case, the metadata value will be the key, right? Or the company name, right? So you will say, hey, run this query text against this company name, run this query text against this company name, run this query text against this company name. And then you will form these three different metadata, different contexts, right? So this was it. I hope you enjoyed this video. If you did, you learned something new, do like, share, comment, subscribe. Thank you so much for your time and look forward to the another video. Thank you so much.